Hi guys, I'm back again. We are continuing with our lesson on center of mass. On the previous lesson, we learned how to utilize masses of different particles in order to determine the center of mass of a system. Now we're going to explore how we can use areas of different shapes to determine the center of mass of a system. In order for you to be able to find the center of mass of a system, considering that you are using the areas, it's important that you familiarize yourself with this table that shows how to determine different areas of different shapes and together with the X and Y coordinates of the center of masses. As we can see for a rectangle, the area its breadth times height, the X coordinate of the center of mass is half the value of its base, and the Y coordinate of its center of mass, it's half of the half of its height. So you have to familiarize yourself with these equations and know how to apply them as well. For a triangle, the center of mass is 2/3 of the breadth, as I can see that it is not shown there. Now let's look into this problem. It says if the object has a uniform mass distribution with a 3-meter B, 6-meter C, 12-meter, find the center of gravity of the object in the below sketch. Now, the first thing first that you need to do when given a problem like this is to break your sketch into different shapes, which will make it easier for you to be able to determine the center of mass. After breaking the sketch into different shapes, you're going to determine the center of masses for each and every shape, and then find the sum and divide by the total mass, and that is going to give you the center of mass of the whole system. So firstly, we can break the shape here, and then we have a right angle triangle, and then we can call this object A, and then we can also break it here, and this will be object B, and then for the third time we can also consider this bigger square here as another shape, and we can label it object C. And then we also have a semicircle here. We can break this shape here and call this object D, which is the semicircle. So this is our shape B, and this is our sketch, and we have 4 shapes in it. There's no any other shape, but therefore now we can continue and label any other necessary information like the length. We can notice that by looking at the diagram, this distance as well is B units. And then we can also notice that this distance from here to here is just a unit, which will be the radius of this semicircle. And then we can also notice that the distance from here to here is as well a unit. And then also the distance from here to here is also a unit. And the distance from here to here, it is as well a unit. Therefore, now we can go ahead and fill in our table as we have for all the required information on our sketch. Let's go ahead and fill in the table, all the unknowns that we need in order to find the center of mass. Now we have A. So we have object A, B, and C. For each, we need to find their areas. So object A is a right angle triangle, and we can see that this right angle triangle is located near the origin. So now the area of a right angle triangle is half base times height. So the area of a triangle is given by half base times height. So this will be the half of the base, which is a unit, and the height, which is as well a unit. So this will be half a squared. And then for B, it's a square, and then its base is a unit, and also the height is a unit. So therefore for B, the area is length times breadth, so that will be a squared, a times a. Now for C, we have also a square with a base which is 6 units, that is B units, and then the height which is 6 units as well. Therefore, our area for C will be B times B, which is B squared. And then now let's go ahead and determine the area for object D, which is a semicircle. Now, something important, we can notice that for object D, which is a semicircle, it's a cutout, right? It's a cutout. It cuts this bigger square. As a result, when we are doing the calculations, we have to actually minus its value from what from what from the value of this a bigger triangle, right? So therefore, that means its area will have to be what? Negative, since it's a cutout. Therefore, we're gonna have minus half pi multiplied by its radius, which is a unit, and then squared. So this is how we're gonna determine the areas of each and every shape that is in there. Now let's go ahead and find their x coordinates and the y coordinates of the center of masses. Like I said, these are the equations that we're gonna use. Therefore, let's continue and do that. For object A, it's a right angle triangle, and then a right angle triangle to determine its center of mass. Firstly, something important you have to take note is that we also consider the distance that the object is located from the origin in order for us to find the center of mass. We don't just take the formula, let's say for a right angle triangle, and say half of the base, and that will be the center of mass. How far the object is located from the origin also affects the value of the center of mass for both the x and the y. So let's see, A, it's located exactly at the origin, as we can see, and the distance from here to here is a unit. Therefore, since it is located at the origin, that means for the x center of mass for A, we simply have 0 plus the half of what? Of the base of object A, which is A. And then let's look at each y center of mass. Each y center of mass, we can notice that this object didn't move any distance up or down. Therefore, even for the y center of mass, we simply have 0 plus 1/3 of the height of this object, which is simply a unit. Now, let's look into object B. And then for object B, we can notice that it is located 3 meters or a unit from where? From the origin. That is the distance from here to here. Let me use a different color. That is the distance from here to here. This distance from here to here, it's what? It's 3 units. It's located 3 units from the origin along the x. Therefore, the x center of mass will be what? Will be 3, which is a unit. Will be 3, which is a unit, and then plus the center of mass plus the x coordinate of the center of mass, which is going to be the half of its base. So its base, it's only this distance from here all the way to here. So that is 3 units, which is a unit. Therefore, this will be a plus the half of a. And then now e to y center of mass, we can see that this triangle, I mean this square as well, didn't move any distance up or down. Therefore, its y center of mass is basically 0 plus the half of its height, which is a unit as well, because this is the distance from where is the distance from here all the way to here. So this is a units. And then now let's move on to the third shape, which is shape C. We can see that along the x-axis, it is located 6 meters away from the origin. Therefore, we're gonna have its y center, I mean its x center of mass being 6 plus the coordinate of for its x center of mass. And how do we find the the x center of mass for a square? It's half of the base, so this will be the half of its base. So when we look at the diagram, we can see that the base, it's only b units, which is 6. Therefore, this will be 6 plus the half of b. 6 plus the half of b. 6 plus the half of b, and then its y center of mass, the y center of mass, even this shape, it didn't move up or down on the y. It is exactly at the origin. Therefore, its y center of mass will simply be 0 plus the half of what? Or for its height, which is b units, which is b units. So therefore, it's a semicircle, which is a cutout, right? So to find its x coordinate of the center of mass, we're gonna consider this whole distance. We're gonna consider this whole distance c from here to here, which is how many units? That is 12 units. So that is basically C units. So therefore, we're gonna have C. But in this case, remember, it's a cutout, right? Therefore, we're gonna minus instead of adding, okay? If in case, let me see, this shape, which is a semicircle, instead of being inside, it was outside like this, okay? Then we're gonna have to say C plus, but now it is what? It is a cutout, okay, located inside, okay? Therefore, we have to say C minus is what? It's the x coordinate of the center of mass. And how do we find it? It's a 4/8. It's 4/8 of what? Its x center of mass. It's 4/8. I can notice that here on the diagram for a semicircle, they basically swapped the x and the y equations on how to find the center of mass for a semicircle. So for x center of mass of a semicircle, it's 4 over 3 pi multiplied by the radius, and the y is just simply the radius. So now let's go ahead and fill in the missing information. So that means we're gonna have C minus, we're gonna have minus C minus 4 over 3 pi, C minus 4 over 3 pi. This doesn't really show that it's a negative here. 4 over c minus 4 over 3 pi multiplied by the radius, which is a unit. And then for the y is just simply the radius, okay? Because look at this diagram of a semicircle, okay? So this is our semicircle, right? You can notice that, remember, the extent of mass is like the middle, right? So we can notice that the middle is basically here. So your y center of mass will basically be located here. So the distance from here to here is simply what? The r units, the radius units, which is simply a. Therefore, your y center of mass for this will be a. Okay, and previously I made a mistake on this table. They didn't really make a mistake. They are right. The x center of mass, if your semicircle is like this, the x center of mass will just be the distance from here, the radius from here up until here, which is r. And your y center of mass, because it is in this way, it's just gonna be what? Somewhere here. So this is 4 over 3 pi multiplied by the radius. But when it is facing like this, then it becomes different. The y is just the length of the radius, and then the x center of mass is the one that is going to be here. Therefore, hence it's going to be 4 over 3 pi multiplied by the radius. Perfect. So now we have filled in the table for the x center of mass. So now I believe we have all the information. We can just continue and find our x center of mass. So in this case, the x center of mass is going to be given by the sum of all the areas AI multiplied by all the areas AI multiplied by the corresponding x coordinate of the center of mass divided by the total area. This is the equation. So let's continue, go ahead and do that. So the x center of mass, x center of mass. So now therefore the x center of mass will be equals to, now let's go back and refer to our table. We have half. So for the first one, we're gonna have half a squared multiplied by, for the first one, okay, I also made a mistake here. Apologies. This was supposed to be 2 over 3. This was supposed to be 2 over 3 because on object A, on object A, it's a right angle triangle. Therefore, this was supposed to be 2 over 3. Let me rectify that. This was supposed to be 2 over 3 multiplied by the base, which is A units. Okay, therefore, for x center of mass, we're gonna multiply AI by xi for each and every shape. So for the first one, it's 1 over 2a squared multiplied by 2 over 3a. So the first one, we have 1 over 2a squared multiplied by 2 over 3a. And then this will be plus. Then the second shape is a squared multiplied by a plus 1 over 2a. A squared multiplied by A plus 1 over 2A, and then plus, then the third shape is B squared multiplied by B plus half of B plus B squared multiplied by B plus half of B, and then plus, and then the last one is minus 1 over 2. Remember, this is negative. It's not that clear enough, but it's a negative. Negative 1 over 2 pi A squared multiplied by C minus 4 over 3 pi A. Right. So this will be, come here. So this will be minus 1 over 2 pi A squared. Multiply this by C minus 4 over 3 pi multiplied by A, close bracket. And then close bracket, and then we're gonna divide this whole thing by the total area. So for the first shape, the area is half A squared, plus the second shape, the area is just A squared, plus the third shape, the area of the third shape, which is simply B squared, and then the last shape, which is minus 1 over 2 pi A squared. And then from here, this, you just gonna substitute all the values of A and B, and you're gonna get that the X center of mass is 6.27 meter. So that's how we go about finding the X center of mass. Now for the Y center of mass, we're gonna multiply, we're gonna find the sum of all areas multiplied by the corresponding Y center of mass for the shape divided by the sum of all areas. So then this is going to be equals to, for the first shape, we have area half A squared. This will be multiplied by 1 over 3A, the Y coordinate of the center of mass for A, 1 over 3A. So this is 1 over 2A squared multiplied by 1 over 3. So first one, 1 over 2A squared multiplied by 1 over 3A. And then this will be added to, for the second shape, area it's A squared. We multiply it by 1 over 2A. A squared plus 1 over 2A. A squared plus 1 over 2A. And then the third shape, which is also a square, we multiply B squared by 1 over 2B. B squared. So this is B squared plus 1 over 2B. And then plus the last one, it's a semicircle that will be minus, so half pi A squared multiplied by A. So that is minus 1 over 2 pi A squared multiplied by A. So even here, you're gonna substitute all the values of A and B. And then after substituting all the values of A and B, you will find that the Y center of mass is 2.36 meter. Hence, the coordinates of the center of mass will be 6.27 and 2.36 meters. as required. And that's how you find the center of mass for this given shape.